All right, so in this video, let's try to use a library to figure out how similar two pieces of strings are. And for that, I'm going to use this library here on GitHub. I'm going to link to this developer's page in the description. We're going to try to use this in Sheets environment. And if I scroll down here, see it gives us an example how it's used. Now, this is not intended for Google Sheets directly, as you can see. So it does do this import. What I'll do, I'll just scroll up here and find this dist section and see if we can use this right away. So this seems to be TypeScript, which may not work for us. So let's try this one. The second one, I'm going to take this TypeScript. Let me take a look and see if there is actual TypeScript here, or this is just JavaScript. Seems to be just JavaScript overall. We have some exports, which we cannot use, obviously, but the actual code of the function here should work just fine, as far as I can tell. So this is what I'm going to do to test this. I'm going to go to Sheets. We'll go to Extensions and App Script. Let's add a script here. So I'm going to do a new script, and I'm going to just call it string similarity library or something. I'm going to remove anything that shows up here by default. We'll go to that library page, to this file, and I'm basically just going to grab, starting from here, I'll grab the comments too, and go until starting from here. See, we need to find the end of this function, which seems to be here, as far as I can tell, right before this exports. So I'm just going to copy that much, go back to our page and paste it here. So there we go. Looks pretty good. I do want to add their license here. So I'll just go back and find the license file. There it is. So we'll just copy all of this, go back here and add some JavaScript comments and paste the license right there. Should be good enough. Now let's see if this whole thing works. So for that, I'm going to add another script. And this one, I'm going to call it my code. I'm going to rename this function. I'll just call it compare strings. And right here, we need to basically run that library, see if that works. And for that, I'm going to go back another one and try to look at their main page. And here, see, there is an example of running that. So I'll just grab this, and it says returns a score. Copied and paste it here, and I'll just save it in some sort of variable here. And finally, just console log this. So hopefully, if all of this was not in vain, we'll find that it returns some sort of score. And basically, it's going to tell us how similar is this string to this string. So I'm going to save this, open this compare strings function, and run this. And as you can see, it gave us a score 0.9. So for example, if we do Linda Smith and compare it to Linda Smith, that should be now identical text. And if I run this, see, we get similarity of 1. It's probably not case sensitive, but let's test it. So again, 1 similarity for lowercase. But if I do Lida without N and run this, see, we get 0.84 similarity between the strings. So far, so good. Now, the next thing I want to do, I want to be able to create something where I'm going to have a list of different words or phrases, and I want to figure out which one is the most similar phrase to whatever it is that I'm comparing to. So for that, let's create some sort of array. And we'll basically just store some things here. So that's going to be my array. What we want to do, we want to loop through this array and run this function. And basically, based on that, get all the scores for each one of these. So for that, I'll take that names array and do something like map. I do map because I want to return a new array with those scores. So I'm going to take each name, or right now, let's just call them word or phrase maybe would be better for this. And then for each phrase, we'll take that phrase and compare it to our actual target phrase. So I'll take this and store it in a variable. So here we're going to run this. Actually, I'm just going to grab the whole line. I'm going to put it right there. And what we'll do, we'll take our target phrase and compare it to the actual phrase from this array. So we'll loop through those and we'll get results. And for now, I'll just return results like this. And really, it's just going to be one result. So let's just call it result. Now this will now return a new array. So we'll just call it results for now. And I'll just console log those results here. Let's try to see what that array looks like. So I'm going to save this, run that, and see I got 0, 0.8, 0.6, and 0. So apparently between Jane Doe and Linda Smith, we got a 0 score. Between Linda Smith and Linda Smith, we got 0.8, then 0.6, and then 0. So we do get scores. So based on this, now we could, for example, choose the highest score out of here and say that's basically our best result. So let's see how we're going to do that. Now, obviously, we could just sort this and then do all this type of stuff, but it would probably be best to not do that. The other thing I want to do here, I want to actually return this results in a little different way. So instead of just returning the score, maybe we can just return some sort of key value pair that's just the name and the score actually. So right here, when I return this, I'll just say phrase colon, and that would be the actual phrase. And then score would be the result. Something like that. And at this point, if I rerun this, see, we're going to get this. It's going to say, so Jane Doe's score is 0, Lida Smith's score is this much, and so on. So as I'm looping through this, I want to actually store the score and basically get the highest one. So I don't want to keep looping through this all over again. Technically, now I could grab this and loop through this and find the highest score and grab that one. But since we're already looping through this, we could just as well at that point store and figure out what's the best match. So for that, let's do a couple of things here. Let's actually scroll down here and create some sort of class. And we're going to call this similar string finder. So that's going to be our class. in this class, let's create a constructor of some sort. And basically, when we create this, we're going to need to give this our target phrase and this list of names. So right here, we're going to have those, our target phrase, and we're going to have phrase list. So we're going to pass these two things to this constructor. And then as we do that, we'll basically do a few things. The first thing we're going to do, we're going to define the target phrase here. So I'm going to say this target phrase equals that target phrase. And then I'm going to say this phrase list equals that phrase list, so that we internally store that inside of this object. So below this, I'm going to create a function. So my function is essentially going to do this. It's going to map through the list and get these results right here. So let's just create a function. So I'll just go below this and I'm going to say find scores or something like that. And because we're in a class, we don't have to use the word function to define the function. We just type the function name like this. And in this function, I'll just grab this thing that I did here and paste it over here, like so. And then instead of this const results, I will just say this results equals, and then instead of names that we have here, that names is going to be this phrase list. So I'll take this dot phrase list. Let's make sure we type that correctly. And I'm going to map through that list. And for each phrase, we're going to do this. And in this case, our target phrase is going to be this target phrase, which is this internal thing in our class. And then we're going to return this. And once we return all of that, we're going to store those in this dot results. So maybe let's not call it results. Let's call it scores. So now this will have this target phrase. This should be phrase list. There it is. The phrase list is phrase list. And maybe initially we'll just say this dot scores equals null. And then we'll run this find scores function when we have this constructor to actually define those scores. So I'll just say this dot find scores, which will run that function over here. And as we run that function, we'll set this scores array right there. So let's see if this idea works so far. So if this is going to work the way it's going to happen, I can now delete this and I can say const compare equals, and I'll take that constructor for a similar string finder, this thing that I've created, and I'm going to pass this target phrase and phrase list, which is going to be for me names. No, actually target phrase is going to be this target phrase, and names list is going to be, or phrase list is going to be this names. So if this works, we should be able to run this, and it's going to set all these things. It's going to run this find scores and get all the scores. And then we should be able to access this scores to get the results, which means I should be able to do now compare dot scores right here. And hopefully if I run this, it will get me the same results we used to look at a second ago. And as you can see, that did. I did get the same results. So now we should be able to access all these different properties like target phrase, phrase list, scores within this compare. Now, all of this I did mainly because I wanted to also store some sort of best match. So again, by default, right here, let's do this dot best match equals null. So then what I'll do, when we go through this, we want to basically figure out what our best match is. And what we'll do initially, we'll just grab whatever the first one is and set it as our best match. So basically, when I do this map and I loop through this, right before we return this, let's actually set it to be our best match. So what I'll do, I'll say this dot best match. Actually, first, let's just store this in a constant. So we'll just say const current match equals, and I'll just grab this. And then I'll take this best match and set it to be that current match. And because it's an object, I'm gonna just do this to make a copy of that. And then finally, we'll return that current match. This will just set that best match to be that current match. But if I just do this, it's gonna just continuously just grab the match and set it, and the last one will basically eventually become our best match. So we don't want to do this all the time. We want to have some sort of if statement for this. So we'll just say if, and let's just move this inside of that if statement. So what we'll do here, we'll check if our current score, this score that we have, is basically lower than the score that we get in our current match, then we'll set it to be our current match. So I'll say if this dot best score or best match. Now I want to have something like score here. But the thing here is that there is not going to be score on this best match at the moment because it's null. So let's do this. Let's actually set this to an empty object here with this arguments in it. And we'll set the phrase to null and score to null instead of having the whole thing as null. So this way we would have the score in this, and we'll check if that score is less than the score that we get from our current match. So we'll take our current match dot score. Then we want to set our best match now to be this current match. The question that we're going to get here, when we get this, and let's say this is null and this is 0. So at that point, we probably want to take that null and make it a 0 as a score. So what I'll do here, I'll say if this score equals null or this, then let's set this. So let's see what happens. My intention is to then come here and be able to console log our best match and be able to get the best match here. So let's run this and see what we get. So as you can see, doing this, I got this, and I got my best match over here, which is actually correct. That's this one. So now we're able to get our scores list. We also get our best match, which is basically this one right here. Now, I guess we have to think about what if we have two things that have exactly the same score. Now, in this particular case, it will just grab one of them. Now, you might want to also handle a situation if they're exactly the same. So in that case, maybe instead of having this best match to be just one object, maybe we can do an array. Basically, just add those matches to that array. So that could be a good technique for this too. As of right now, I don't care about it. I'm just going to leave it like this. So we have a way for us to pass now a list, and based on the list, figure out what the best match is for our string. All right, so now I want to set some sort of minimum score so that, well, right now, if we look at this, even if every single one is 0, it's going to still set one of them as the best match. We probably want to have some sort of limit to say if the score is, say, 0, 6 or higher, then it's a match. Otherwise, it should not be a match. What I'll do here, I'll go to our constructor and we'll pass a minimum score. And by default, we'll set it to be a 0. And then down here, we'll set that minimum score to just be that minimum score. So at this point, when I have that minimum score, when we go to find these scores, we want to check for that minimum score to actually consider that a match. So right now, when we check this results, we get the string similarity. This result is going to be that score that we get. Maybe we should rename that to actually just say score instead of saying result. Like so. Then we want to check if that score is above whatever that minimum score is. So I'm going to say if our score is basically less than that minimum score, this min score, then this should really not be a match. We shouldn't really do this best match thing at that point. But we still want to return that in our scores list to see what that score is. So therefore, what I'll do, I'll just move this down here. And we'll, at this point, return that current match. So that's going to mean we're not going to go here and we're not going to set a best match. So let's save this and go take a look. So that means now if I go back and rerun this code, I should be getting the same thing, this. But if we, for example, remove the stuff that's close, like these two, and actually we also need to pass a minimum here. Let's say the minimum is 0.6 or something. If I run this, see, our best match is null because none of these pass the required condition. Now, if I go back, put this back, and let's say now we have 0.8 as the limit right here, and we don't have this one. And we run this, our best match is still null. Because if you remember, this Anna Smith doesn't pass that 0.8 limit. But if we do something like 0.5, then we should get at Anna Smith as a best match. Okay, good enough, I guess, for what we're trying to do here. So now we have our target phrase, names, and then we have basically this minimum score if we want to use it. If we don't, we can skip that and it's basically just going to be 0 by default. All right, so now that we have this, I don't want to probably console log our scores anymore. So we can now just get our best match like this. And then if we wanted to get what the match actually is, we'll just do best match dot phrase, and that should give us the best match from this list. And it will say that the best match for this is this. So now, as I have this, let's try to use it in our spreadsheet environment. And the first thing I'm going to do, I'm actually going to move this class to its own file. We'll just save this over here. I'm going to move this one up to be above this, just to make sure that is available by the time we get here. So let's now try to get this information to our spreadsheet. And our initial text was this. So my intention is to go here and do something like get best match. Click on this, comma, and then give it this list, close parentheses, and I want it to return that best match, which would be this one. Maybe we can also pass this parameter here after comma, which is going to be percentage as a minimum. So I'll go to here. I'll create that function. So this will be our target phrase. This will be that list. I'll just call it phrase list. And then finally, this last one is going to be our minimum score. And again, I'll give it a default 0. So now within this, we can now use this basically. So I can just paste it here. And my target phrase is going to be this target phrase. Now this phrase list, the default way it's going to come from our spreadsheet is going to be some sort of list of lists, assuming it's going to be a column. And if it's a row, it's still a list of lists in a different way. We basically need to convert it to a regular JavaScript list. So I'll just map through that list. And for each row, because it's going to be a range, I'm going to just basically return everything from the first column of that row. And we'll just save this in a variable. And then I'll just pass that right here as my reshaped phrase list. And then finally, this minimum score is going to go here as our minimum score. And at that point, we're going to get this compare. So we'll finally just return that compare dot best match dot phrase. So let's save this and see if this works. I'm going to go here. Hopefully I don't have to refresh this. So nothing. I'm going to have to save all of this and I'm going to try to refresh this. And it doesn't seem like this works. So I'm going to go back and see what's going on. Let's just take a look at our executions. So it says completed, doesn't give me any errors, which is kind of surprising. Let's go back and take a look. So let's try to do some sort of console log here to see what this thing looks like. So I'm going to do console log and we'll do that compare. So I'm going to go back here. We'll just try to change something here so it reruns the function. And we'll go back to our executions and take a look. So apparently we got null. Nothing passes. In this case, that 0.8 minimum score based on this values that I have. So let's go and make sure I enter things in a way that actually does give us a good match. And this also like that. So now we get our function that gives us these results. Now I want to be able to use this function in a way that I can just maybe just do this, like the whole column. I should be able to do it right now, but I'm going to have to force this to go through every single empty item in this list, which is not great. So what I'll do when I do that transformation right here, so instead of just returning this right here, let's just filter anything that's blank from that list. So before I map this, let me actually filter this. So maybe we should actually just create a new variable and run just one for each loop for this. I'm not going to worry about efficiency right now. So let's just get it to work at the moment. So we'll just take that R0 and make sure it's not equal to blank. So this way it should filter the list to not have any blanks, and then we would compare whatever's left over, and that way it's not going to have to run through that list. So let's give this a shot on a different list and see if this function operates. So I'm just going to type some items here. So let's just enter some word here and see if we can find a good match. So that should be pretty obvious what should be the best match for this. So we didn't do autocomplete for this function, at least yet. So we're going to have to just type that manually. So here my value is going to be this. My array would be this. And maybe I'll just lower this to 0.5. That seems to be good. So it found the right match for tomato. Now let's try to do something like berry. I guess that's pretty good. So if we do blackberry, that should find blackberries. So this would obviously make a lot of sense when you test it with larger sets of data. But for this small examples, it seems to work pretty well so far. So what if we don't have berries here? What would be, let's say, the best match for this? Apparently none of them. So it didn't find any of this to be a good match. Now I'm pretty sure if we go here and lower this to a lower score, it will find one of them to be the match, which in this case, blueberry, I guess, because that was shorter, closer to berry. So there we are. So we seem to have something that actually works. So if we had a list of stuff here, well, let's add apple here maybe. Now let's try to drag this formula down and see what we get. So berry, we got potato, potatoes, tomato, tomatoes. That's bananas, pretty good. Pineapple, apple. So if I now lower this percentage to say 0.5, let's see what happens then. Yeah, we get less matches. Apparently that's the first one that went away. Let's do a little higher, 0.7 maybe. So I'm going to expect that's going to drop apple at this point too. Apparently that also dropped this one, the mismatch for bananas. It's not bad. So that's our score. We got our word and we got our best matches. So there we have it. We got our function that's going to compare our strings to get the best match. Now we could add a little bit of, I guess, function documentation here. Now I'm going to go back to this. I think this should help us, so I don't have to type the whole thing. So I'm going to copy that, paste here. So we'll just say get best match from a list. And our first parameter here, it's going to be this target phrase. And then our second parameter here, that's going to be this phrase list, which is really going to be a range, I guess. Actually, let's call it column range because it cannot be rows right now. And then we got our third one. So let's see if we get some autocomplete for this. So if I go back here and do equals get, well, I don't get it right away. Let's just try to refresh it and see if it still doesn't do that. Well, it doesn't. It's not good. So probably messed up in the way I wrote those comments right here. So let's try to go and look at their docs and see what it should look like. Here's their documentation. Let's scroll down. This is pretty much what I want. So apparently this is the part that I've probably missed. It should probably say custom function. So let's try to copy that and go back to our function and add that here and see if that's enough. I'm going to save that, go back. There it is. So get best match. It gives us this here. So we have target phrase, phrase list, and minimum score. And then we have phrase list right there. And it should give us probably more column range of strings, which is pretty much the stuff that I did there. And then finally, we have our score. And then we should be able to drag this down. It should work the same way. So we made a function. Obviously, there are a lot of things that could be improved here. This could be improved to also handle, let's say, if you select a row of data instead of columns, you can handle like what data is being passed to it. You can make it also work with arrays and stuff like that. But that should be a good base to try this with different data sets and see how it works with different strings. And maybe if it does work, it's maybe worth to spend more time on this. But for now, we at this point really don't need this anymore. And that should be our custom function here. This is basically the main library we did. Calculate the similarity score, which is right there. Then this is the wrapper I did around that to basically just get the best one. And then finally, this is another wrapper around that one to basically just get a function in our Google Sheets that gets our best matching string. And that should do it. Thanks for watching. Please subscribe, and I'll see you in the next video.